Hey, hello and welcome back again to another video tutorial of Roy's Academy. In this video tutorial, I am going to discuss on a very important aspect of the food processing area, which is obviously coming under the diverse field of food science and technology. Now, in this particular discussion today, I am going to deal with or discuss with the comparison between the processing style and concepts between the ready-to-eat and ready-to-cook food products. Now, the ready-to-eat food products. What are these ready-to-eat food products particularly? The ready-to-eat food products are nothing but the food products which can be instantly consumed in order to beat the hunger. Okay, and the ready-to-cook food products are nothing but which can be instantly cooked, either in boiled water or either in the oil, and can be served in a hot platter kind of thing, or a hot plate with any kind of recipe as per the requirement. Okay, or the requisite as per the whatever the occasionally whatever the purpose may be, based on that purpose it can be served. Now the thing is, both of these are coming through the process, through the concept of extrusion processing. Okay, extrusion is nothing but mixing all the ingredients, desired ingredients together, and passing it and melting it, transforming it into a slurry or paste like appearance, and plasticizing that all those ingredients into a particular form of slurry and pumping out the slurry through the die cutter. Now through the die cutter, when the slurry is being pumped out, it is being transformed in the particular dimensions that are important for getting packed, right? So these are this is how the all the ready to eat and the ready to cook food products are being processed. Now let us have a look that what are the ingredients that are being used and how the comparison between the processing is being drawn among the ready to eat and ready to cook food products. As for example, the ready to eat food products are like the chips and snacks and all, the peanuts, the flaked peanuts and all, chocos and all, cornflakes and all. Okay, cornflakes can be assumed as ready to eat as well as ready to cook food product also, or ready to serve also. And on the other hand, ready to eat there are chocolates, protein bars are there, confectionery items are there, cakes are there. Okay, these are ready to eat. Directly after opening the packet you can eat. And in case of the ready to cook food products, we are having the pastas and all, spaghettis, ramen noodles and all, chow mein and all. Then there are some kind of papads and all. Okay, expanded food products are there, and dehydrated food products like dehydrated fruits, berries, vegetables and all, dehydrated rice, which is coming with seasonings and all within the packets, which is being packed with excess preservatives and all, okay, in nitrogen flushed packets and all. So these are some of the ready to cook food products. Now in order to maintain majority of these ready to cook or the ready to eat food products, in order to make them, the majority of the food products are requiring the rice as well as the wheat starch. The wheat starch or the corn starch, as well as the rice starch is being required, because wheat is very much essential, because wheat is having gluten, the polymeric protein chain structure, which is having glutenin and the gliadin structure, as well as the corn starch is having the starch. Now these two particular proximate compounds of food, the starch and the protein, are having a peculiar kind of advantage in producing this kind of food products, the instant food products or the expanded food products like the ready to eat, ready to cook and ready to serve. The thing is, when these food products or the raw ingredients are getting processed within the barrel of the extrusion chamber, all this starch and the protein chains are being broken down into simpler monosaccharides units as well as the amino acid or the simpler oligopeptide units. Okay, this is nothing but the short chain structures or the monomeric units of the proteins as well as the carbohydrate. Now in course of the processing, when the temperature rises up in above 120 degrees Celsius or reaches up to 170, 180 degrees Celsius within the extrusion chamber, this starch and the amino acids or the oligopeptide chains have a special capability of realigning among themselves and creating a different kind of altered texture in the product, altered structure, and as well as an altered texture, giving it a completely different kind of consistency. Okay, it creates a cohesion between it creates an adhesive kind of appearance. Same time it is syrupy in nature, same time it is glutinous in nature, it's sticky in nature, and same time it is jaffy, like sticky, too much sticky. Okay, elastic in nature, less elastic in nature. Okay, rubbery kind of, stretchy kind of appearance. So this is the reason why the gelatinization, the retrogradation, the synergesis properties of the starch comes in, and in case of the protein, the denaturation and realignment of the amino acids or reformation of the amino acids along with the starch gains are happening. So let's have a look that how the comparison is being drawn among these two things. Okay, firstly, ready to eat processing of ready to eat versus ready to cook. Okay, so in this process I am going to discuss that firstly there is what we have, the raw ingredients. Firstly, let's make a box of the raw ingredients. Okay, so this is the box of the raw ingredient, and now these raw ingredients are, like I said, these are nothing but wheat, is there, plus rice starch or corn starch. Okay, now the wheat protein content, WPC, the wheat protein content is nothing but the gluten index. Okay, the gluten index that we are having, the wheat protein content is nothing but the content of the wheat protein that is present in the wheat actually, which is giving the glutinous appearance or the reformation, the refurbished texture actually is nothing but the 5%. And this rice starch is giving the carbohydrate content, the carbohydrate or the starch content, carbohydrate content of 50%. Okay, so just see that with the 5%, only the 5% of the gluten content, the starch content is getting refurbished, replenished at the same time. Now this is all about the wheat protein content and the rice starch content. Okay, or the corn starch, if it's the corn starch content is also given, it's little bit higher. In case of corn starch content, the carbohydrate content, that is being indulged, okay, entertained for this purpose, particular purpose, is about 60 to 80%. The reason is the corn starch or the maize starch is kind of having when the starch is having a soft structure. Unlike the rice starch is having too much of the amylose and amylopectin chain. In case of maize also, maize is containing the more or less a considerable amount of the protein structure also, and as well as the starch structures also, the starch content also. Now the maize starch is kind of sophisticated, that is during the course of processing, if higher temperature is being achieved within the extrusion chamber, the corn starch or the carbohydrate content would gradually degrade. For that reason, the corn starch is given little bit higher, because the corn starch is more fine in nature rather than the rice starch. So if in order to make it jaffy or adhesive, the corn starch content is usually introduced a little bit higher compared to the rice starch content. Now after this raw ingredient section, we will come directly to what? The pre-mixing condition. Okay, the pre-mixing condition. Pre-mixing. Now in this pre-mixing condition, what we do, generally in this pre-mixing condition, what is done is the additives and the flavoring agents are being added generally. But in pre-mixing condition, another thing is added. In the field of additives, or in the branch of the additives, the pre-mixing is actually mixing all this wheat, rice starch contents, these raw ingredients together with the aid of a good colloid, good emulsion, good dispersive medium, and that is assisted in the, that is helped out. This pre-mixing is being done with or helped out with milk. Okay, it is done with milk. Now the milk is given 5%. Okay, milk along with another thing it is given here, that is butter. Butter is also given 5%. The reason why milk is given is milk is having all the vitamins and the elements except vitamin C and iron. Okay, so most of the nutrients, the macro elements as well as the micro elements except iron, and most of the vitamins as well as the milk protein, the milk fat and the milk water is acting as the colloid, that is a dispersive medium in order to mix the ingredients properly, and the butter is acting as a plasticizing agent in this case. Okay, so that's why the butter is given only 5% and the milk is also given only 5%, because if too much milk and too much butter is being given, then the post processing, that is after extrusion, the post processing would be difficult, and making the product a dough like appearance within the barrel, within the extrusion chamber, giving an adhesive appearance would be difficult if too much suspension or dispersion is been done, or too much plasticizing agent is been given. The product would become a product loss, that the achieving the final dough like appearance or the adhesive texture consistency of the product would not be possible. The majority of the product would remain added, or there would be product loss. Okay, the product loss would be there, the majority of the product would be lost over the screws of the extrusion machine, screws of the extruders, right? So this is the percentages which are needed to be looked for. And after pre-mixing comes another step, which is called the final step, or the important step, called extrusion. Extrusion is nothing but kneading, punching, forming, shaping, shearing, and kneading, punching, forming, shaping, shearing, then pounding, dicing, cutting. Okay, these are all how the extrusion process happens. Extrusion process is nothing but kneading. Kneading means just like we knead a dough, it's mixing and pounding, repeating the process, that we make a dough kind of appearance, like we make atas and rotis, the doughs in our home traditionally. We mix all those things and then again go on repeating the same process by holding one, by taking into account a section or one point of the entire dough, and then again repounding or pressing it over the remaining portion or the remaining area of the dough. That is what kneading is. Okay, punching. Then punching means it's pressing the dough, entire mixture or the premix against the wall of the barrel within the extrusion chamber. After that, it is the forming. Forming means shaping the product. Then shaping is nothing but the shaping the product, and also there are another important part present here. Before cutting, here it would be melting. Okay, melting and plasticizing. Melting and plasticizing and plasticizing. Okay, Then forming means it's realigning, reformation or refurbishment of the starch and the protein chain structures. After that, shearing is also been. Shearing means putting too much stress and strain during the course of premixing, so that all the product gets equivalently or uniformly mixed with each other. Okay. And after that, melting means too much high temperature when it's being achieved in case of hot extrusion or HTC extrusion. Then 170 to 180 degrees Celsius, the product starts liquefying. The entire chain becomes too much slurry kind of appearance or slurpy. After melting, it's obviously getting plasticized, and then again pounding, reducing the temperature, pounding, venting off the excess heat, and finally dicing and cutting, and then going to the post process or final process. So these are all how the extrusion is working. Now, after the extrusion, from here we have two different sets actually. Two different sets are present. Okay. Now let us have these two different sets, one for the RTC or the ready to cook, and another one for the RTE, ready to eat. Now in case of, obviously in both of these two processes or the product formation, the process would be different, right? Now in case of RTE or ready to eat, after this extrusion process comes the process of drying. Drying is essential because it helps in removing the excess moisture. In this case of drying, like the tray drying or batch drying, almost 90 to 92% or maybe 95% of the moisture is being removed. Only hardly 2 to 3% or 5% moisture remains, which is not even countable, okay? Because most of the moistures are getting removed. Like in case of the chips and all or cornflakes and all, you see that it's totally crunchy. It's not having any kind of sogginess, okay? So after drying, it's the next step that is coming, that is known as flavoring. Flavoring means adding certain seasonings and all, masalas and all, in order to make it enhance the taste of the product. Okay, like in case of the chips and all, the instant snacks that we eat, the cake and all, the cookies and all, biscuits and all these things, every kind of ready-to-eat products, flavoring is coming. And after the flavoring flavoring step, the final step that is coming here is packaging. Okay, now in case of ready to cook food products, the process is little bit different. In ready to cook food products, what happens after the extrusion process immediately is cooling. Cooling the food product. And after cooling the food product, what happens is drying. Now after drying, another step, the next step that is being encountered by this process is frying or air puffing. Frying or air puff. Now, I need to explain. Let me explain something here. These ready-to-cook food products are being cooled. Okay. So after extrusion directly, cooling process is coming. Why? Because these ready-to-cook food products, like the pastas, noodles, and all, if they are being subjected to very higher temperature, then making the hard, more fracturable consistency of these products, like the pastas, macaronis and all, noodles and all, or some of these noodles, like Chinese noodles, Korean noodles, are when they're dry, when they're in the packet, they're very much hard. Why? Because the refurbishing or the reformation or realignment of the starch and the gluten chain is kind of it requires, in this case it requires less temperature, less heat. Because if the refurnishment of this starch and the gluten chain is not that much consistent, and now is not that much adhesive, or not that much dispersive with each other, distributive among each other, then what will happen? The hard structure, the fracturability of the product, or the hardness of the product would not increase. Like we have pastas and all, the macaronis and all, as for example, then dehydrated foods and all, it becomes hard after dehydration, right? Or fruits or vegetables or nuts, even also nuts and legumes and all, it becomes hard. Why? Because this is the reason why it's becoming hard. Because if we cannot achieve the hardness of the product by cooling it down to subsequently lower temperatures after the extrusion process has happened, then in the subsequent cases the product would not be robust. It would be radical in sense to have the same extruded product in the form of cooking form if we directly subjected to drying before cooling it. Before cooling, if you subject to drying, if you directly put in this step, in case of the ready to cook products, we cannot have that radical or that palatable appearance, that qualitative appearance that is needed, right? So it would not fulfill the aesthetics of the end consumer. And obviously fulfilling the aesthetics of the end consumer in different course of times or different set of requirements is very much what the industry is focusing on. That is how the industry is blessed with these ready to cook and ready to eat food products, right? They are too much rational in that particular sense, or logical, that how both of these two processes can be distinguished just by a single step, that is cooling. Okay, now after cooling, it's coming the drying. Drying means the removal of the moisture as usual, and after drying, the frying or air puffing is coming. Why? Because you see, the noodles are tangled with each other. It is having a kind of meshwork like appearance. Okay, the strands of the noodles are tangled. Now in that case, what happens if the air frying or air puffing is not done? Then the smoothness of the noodles, or the non-adhesive property of one strand and along with the another strand of the noodle would not be there. The foaming property would not be there. So the air puffing is done. And another thing is, this air is not the atmospheric air, because atmospheric air would have oxidizing property. Why? Because the butter, that is the butyric acid, saturated fatty acid, which is given in 5% in the premix, and also during the extrusion process, the wheat and the rice starch and whatever the ingredients have been given, the butter can become easily rancid. It can be oxidized. The peroxide free radical formation might happen in the presence of the atmospheric air, puffing or frying of the product, frying of that particular end product. But we don't need that, because if that the product becomes rancid, it will become off flavor. It would become pale in taste, which is not marketable at any way, and inhygienic. Right. So the air puffing, the air that is being needed here is deoxygenated. It's mostly the hydrogen air, deionized hydrogen air that is being used, or nitrogen gas that is being used, or inert gases. Mostly the inert gases that are being used in the industries, in high pressurized container. That particular air is here needed for the frying and air drying purpose. Okay, which is also known as flash drying. And the air drying also has another important, it also helps in flash pasteurizing the noodle like products and all, the vegetables and all, whatever it is. Now after this air drying step comes the flavoring step. And after the flavoring step comes the packaging. Okay, so this is how the thing is. Now, another question is that the same extrusion process which was subjected to drying, and the same extrusion process which is the same extrusion process, if it is in ready to eat food products, we know the temperature rises to 170 to 180 degrees Celsius, often to 150 degrees Celsius. From 120 to 150, the temperature range is like that, because if that temperature is not reached up, the excess moisture cannot be vented off. Expansion of the food products like the would not be possible, even if you dry the food product, okay, because at that temperature only at the maximum melting of the food product can be done, and the product can be given the desired kind of consistency, the desired kind of mouthfulness, okay, even before drying. Now in case of the extrusion, what we have, there are when the same extrusion process is achieving so much higher temperature for producing these expanded food products like the RTEs, the snacks and all, the instant snacks, instant biscuits, cookies and all, which is having high baking temperature, okay, high frying temperature or high extrusion temperature. Now, is it true, or is it necessary, or is it possible that to achieve that same temperature for the ready to cook food products? Because I said that cooling is needed, right? So even if the extrusion chamber is having too much higher food product, too much higher temperature, then it would denature the most of the protein, and denaturing the protein to a larger extent, or degrading the carbohydrate polymer to a larger extent, would not be benevolent to reform or refurbish the alignment of the carb molecules and the protein molecules or oligopeptide molecules among themselves, in order to give that a sticky or hard, highly fracturable, less fracturability or high elastic appearance. Remember, less fracturability, high elastic appearance, less brittle appearance for the pastas, noodles, the dehydrated vegetables and all, dehydrated fruits and all, dehydrated nuts and canned nuts and all whatever it is, the ready to cook food product, whatever they are out in the market. So what is the difference of these two? How this through the same extrusion, how this drying, the two different kinds of products have been achieved even prior going to this post processing. This is the pre-processing condition, pre-processing step. This part is the pre-processing, okay. And this part is actually the post process, okay, after the extrusion is being done. So is it possible to attempt the same extrusion concept or the same extrusion technology for these both RTs, the ready to eat and the ready to cook? No, there is still difference, because what happens is, in this extrusion for the ready to eat food products particularly, hot extrusion is being achieved, hot extrusion is being incorporated, and in case of the ready to cook food products, the cold extrusion is incorporated. So in case of these ready to cook food products, the cold extrusion, the temperature in case of cold extrusion, in this case the temperature in case of the cold extrusion is about 45 to 50 degrees Celsius. Remember, in this set of temperature only, or max to max, this temperature might rise to 85 degrees Celsius in order to gelatinize the starch, and then the temperature is reduced to 75, 65, like this the temperature gradually reduced in order to retrograde the starch, and during the time of retrogradation only, the starch would start losing the water molecules and realign among themselves along with the intermediate peptide chains. The starch molecule would, the carbohydrate molecules, the carbohydrate monomers and all would acquire the peptide, the protein monomers between among themselves in the network of the it's like it's just imagine how a spider is catching its prey in its spider's net, and imagine that spider's web is here the starch chain, the amylose and amylopectin chain, and that amylose and amylopectin chain is catching its prey. The prey is nothing but here the oligopeptides or the amino acids, okay. And now when imagine along with the prey, the spider is wrapping the prey in its web in order to kill it or choke it to death. This is what the ambush of the spider is. This is what nature, in nature, the spider has adapted its hunting skills. Now here also the same thing is happening. The amylose and amylopectin start chain is engulfing or catching in the oligopeptide chain. Okay, it's actually coating over the oligopeptides or the protein chains, and helping in formation of the refurbishment of a different kind of desired consistency, having the starch coated over the proteins or oligopeptide chains. So it's basically it is helping in attaching the oligopeptides or aligning the oligopeptides within the starch chain, within the amylose and amylopectin chain. Okay, it's forming a bond. It's trying to hold it hard, firmly. It's holding it firmly, holding the oligopeptide chain firmly and coiling itself. That is when that is what happened if the temperature is gradually reducing from 85 to this desired set of temperature 45 to 50 degrees Celsius. That's how the desired consistency of the pastas, the noodles and all, the macaronis and all are coming. Okay, in case of particularly this wheat and rice starch induced food products. Now after this cold extrusion, again cooling is done. Again the cooling is done in order to make it more hard. After that drying is done, then puffing or air frying in order to reduce the stickiness or glutinous property among the tangleness of the noodles and all for proper packaging. And after that flavoring has been given. Now this flavoring here is optional actually. Optional, because the reason is why the flavoring here is optional, because in the macaroni noodles packets or dehydrated fruits and vegetables packet, we have an extra separate seasoning packet or a taste maker packet, right? So the flavoring agents are given in the separate packet, or might be in some cases, in some noodles are there, like some Korean noodles are there, some Japanese noodles are there, where along with the noodles some edible color or edible dyes and edible taste makers are already processed without having a separate seasoning packet within that. Hong Kong noodles are there, Zhejiang noodles are there, Dang Dang noodles are there, the Chinese, different kind of noodles are there. And in case of some glazed fruits and vegetables, where glazing agents like sucrose crystals, fructose crystals, or edible confectionery crystals, the glucose crystals and all, whatever it is being added as a glazing agent. Also some edible dyes are also added as a glazing agent. Chocolate sauce is added for enrobing it as a glazing agent. Okay, some glazing agents are being added. Then there are some artificial chemical compounds which are given in the permissible limit to make it edible or non-toxic or not harmful and safe for the consumption. So this flavoring is optional, because in this case what happens is this flavoring agent can be introduced along with that end product before packaging, or that flavoring can be given as a separate seasoning packet or a separate packet within that master packet of the entire product. So this part here is optional. After that finally it goes for packaging. So this is how the processing of both the ready to eat and the ready to cook food products happens. The comparison between these two processes is very much necessary in order to know what is the real science behind it and what is the temperature of this extrusion. In case of the hot extrusion, the temperature is above 120 degrees Celsius, greater than 120 degrees Celsius. Okay, greater than 120 degrees Celsius. Okay, in case of hot extrusion, because if the hot extrusion is not done, then melting the product to that desired consistency or to that limit, to that extent, is not possible to achieve within the extrusion barrel, right? So this is how all about the comparison between the ready to eat and the ready to cook food products, and how are the processing done. So if you like this video, subscribe this channel positively and share the video as much as possible. Also hit the thumbs up button and comment down in the comment section below. Thank you.